Greetings of the day, dear students. This is an initiation by Department of Collegiate and Technical Education, and we are here to discuss on consumer electronics, which is the Unit 1 of Application of Electronics Engineering for 5th semester diploma students, and the session is 4th session. Department of Electronics and Communication Engineering. In the last two sessions, we have seen the introduction of consumer electronics, and thereafter we have seen the very humble calculator. In very detail, we have seen the calculator, and after that, we have seen the microwave oven. That too we have seen in detail, and now today we are going to see the very helpful washing machine. As you can see in this picture, almost everybody has seen this washing machine. This is a semi-automatic washing machine which we are seeing on the screen right now. It is having two separate sections. One is for the wash section, the other is for the drying section. Now, what is a washing machine? The machine used to wash the various types of clothes. Washing machine is a machine used to wash the various types of clothes without applying any physical efforts. That means we are not physically pained to wash our clothes. With washing machine, you don't have to rub the clothes with hand or squeeze them to remove the water from them. This is all done automatically by the machine. Wash your clothes automatically without having to supervise its operation. Even we need not to supervise the operation, how it is done. And the washing machine automatically takes the amount of water and detergent required, and it also automatically sets a timer for washing, rinsing, drying as per the selected mode and the amount of clothes. As you are seeing in this slide, there are many different versions of washing machines with great advantages are coming in the market nowadays. But these two models, one is top loading model, the other is front loading module. They are the high end modules of washing machines. Today we are going to see regarding these high end washing machines, how they work, how they look like, and what are the different parts they have. These are typical controls and features of a top loading washing machine. As you can see, the top, the first is lid, second is bleach input. From here you can input the bleach if required. Then the third portion is the transparent lid is there, or window you can call it. And then there is a fourth front control panel. Then fifth, softener case. Sixth is adjustable legs. With the help of this we can adjust the height of the washing machine. Seventh is water supply hose. This hose should be connected to a tap. Then eighth is a lint filter, which collects the lint in a small bag. Ninth is a drain hose hook. 10th is power cord certainly the washing machine need a power supply 230 volts, which is available in India. So this cord should be connected to a 3-pin plug, and there is a 11th pulsator. This is the main pulsator which washes or rinses the clothes. And then there is a 12th one, drain hose clamp. Actually, the drain water should be drained out through this hose, so it is clamped to the machine. 13th is a drain hose. Now, as you can see in the slide, the construction and working principle of washing machine. This is, we are not talking about the semi-automatic washing machine. This is, we are talking about the automatic washing machines, which you have seen in the second slide, that is top loading and front loading washing machines. Since we are here to know more about the washing machines which are having mini microcontrollers, so in this you can see the block diagram of a washing machine which is having a PCB, a small PCB, which is mounted with a controller, and there are many inputs and many outputs to the controller. The control part contains a microprocessor or controller based board or a PCB with interfaces to the sensors and actuators. Certainly there are many sensors like water temperature sensor, drum speed sensor, water level sensor, door closed switch, it is also a sensor, and push buttons, they are also having miniature sensors, and then the sensor data is fed back to the control unit, and the control unit generates the necessary actuator outputs, action outputs. That is what is actuator outputs. The control unit also provides connectivity to the user interfaces like keypad for setting the washing time. With the help of this, we can set the required washing times, selecting the type of material to be washed, like light material, medium material, or heavy materials like jeans and all. And then there is a user feedback is reflected through the display. There is a small LCD display. With that, you can see what I have selected and how the machine is taking the course. In a washing machine, the actuator part consists of a motorized agitator. Agitator, as you all know, the main heart of the washing machine, which moves around and actually it washes the clothes. There is a tumble tub, water drawing pump, and inlet valve to control the flow of water into the unit. In the top loading, the agitator of the machine twists back and forth clockwise and anti-clockwise direction and pulls the clothes down to the bottom of the tub. The clothes work their way back up to the top of the tub, where the agitator grabs them again and repeats the mechanism continuously. So in this way, the clothes are washed in a machine. In front loading machine, the clothes are tumbled into the water over and over again. This is what happens in the first phase of washing. In the second phase, in the first phase of washing, the agitator takes care of washing the clothes, and now in the second phase, the water is pumped out from the tub, and the inner tube uses a centrifugal force to bring out more water from the cloth by spinning at several hundred rotations per minute. So when the internal tub, it spins at a very high speed due to centrifugal force, the minute water particles which remain in the clothes, they come out due to centrifugal force, so thereby making the clothes dry. In the keyboard panel of the washing machine, we can make use of the buttons called wash, spin, rinse to configure the washing stage. The inner tube contains a number of holes, and during spin cycle, the inner tube spins and forces the water out through these holes to the stationary outer tub, from which it is drained off through the outlet pipe. So as you can see, the controller is connected to the inputs, the user push buttons, water temperature, drum speed, water level sensor, door, and then there is here you can see the output, and then there is a drum motor here, the water heater is here. Some of the washing machines, the latest washing machines, they do have the water heaters to heat up the water, and then there is a water pump to pump to get the water in, then water valves are there to get exactly how much water the machine needs to wash the different types of clothes. Then there is a user display here, as you can see. Then there is a door release button. Sooner the door is released, the motor stops. As we have spoken regarding this electronic controller for the washing machine, microcontroller to control their various functions, replacing the electromechanical controlling used in the earlier models. The earlier models, or as we call it, semi-automatic washing machines, they were not using the electronic PCB or the ICs into it, but they had electromechanical controlling. Clock circuitry used to time the operation. Certainly the clock circuitry, that means it used to use the spring loaded clocks operation of the machine, and then the display is to be internal. They didn't have any display features like auto off timer, reversible impeller, etc. Most of them equipped with electronic timers. Drum is required to rotate at different speeds, 30 revolutions per minute, while clothes are washed intermediate speed of about 90 rpm rotations per minute while the water is pumped out, and then high speed of either 500 or 1000 rpm to spin and dry the clothes. And now the concept of fuzzy logic. Nowadays we are all seeing many advertisements regarding the washing machines. They quote the fuzzy logic. So exactly, fuzzy logic washing machines are gaining popularity. Here you can see the advantages of fuzzy logic: performance, productivity, simplicity, and still cost less. These machines offer the advantages of, as I told, performance, productivity, simplicity, and less cost. Sensors continuously monitor varying conditions inside the machine and accordingly adjust operations for the best wash results. As there is no standards for fuzzy logic, different machines perform in different manners. There is no standard in fuzzy logic, so different companies, they manufacture different machines in different forms, and they perform in different manners. Typically, fuzzy logic controls the washing process. Water intake, water temperature, wash time, rinse performance, and spin speed. This optimizes the lifespan of washing machine. More sophisticated. Nowadays, the more sophisticated washing machines weigh even the load. Advise us to take out some clothes if it is heavily loaded. Even advise the required amount of detergent with the help of load. Assess cloth material type and water hardness, and check whether the detergent is a powder or a liquid. Some machines even learn from past experiences, memorizing programs and adjusting them to minimize the running costs. This is what is concept of fuzzy logic. The references, as you can see here. Thank you for watching this, and certainly after this 10 MCQs will follow on this very subject. Uh, Try to see all those questions and answers, MCQs. Thank you once again. Thank you so much.